Okay. Um, yeah, so this is Lab 7. You're going to be dealing with maps. Like I said, we went over or the maps that is, we went over maps last week if you showed up. So how to use a map, you guys should be familiar with at this point, but this lab will actually help you implement those and get more familiar with the syntax and everything. Uh, so this lab is broken up into two parts. So the first part is going to represent somebody rolling dice. That's the user. So they're going to be representing you rolling dice with your system. They're going to give you three inputs. They're going to give you a random seed value, which we'll talk about in a second, and they're going to give you a number of times to roll the die, and they're going to give you the number of sides of the die. Okay, so basically it's the number of sides and then how many times I roll it. And what the output is going to be is the each individual side. So for this one, it's 1 through 9, and then the right hand value is going to be how many times that number was rolled. Okay, so you're going to be using a map to store this stuff. So basically, you're going to have a key and a value. For this, your key is going to be the number rolled, which means your key is basically just the number of each side. So these are all the key values on the left-hand side. And then the number of times it is rolled is the actual value for that map. Okay. So that is kind of like the data structure and what you guys are using to make this work. On the note of the randomness, so he already has this set up for you guys, like in the code. And he actually deals with seeding the random function, but I will talk about the seeding just so you guys are familiar with it, because you will need to use some kind of random functionality for project 3. Um, so with this random function, basically he has a random variable that's set up. This is just a library. And with this random variable, he can set up some type of distribution that has a minimum and maximum. And he basically just returns a value from that distribution. So in this random function that he made, you guys will call this random function with a minimum or maximum value, and it will return a number from that minimum to that maximum. Okay. Um, these random values need to be seeded. So when we talk about seeding in computers, especially with randomization, this is because computers can't really do random. Like if you asked a computer to spit out a random number, it'll just be like, okay, how, or which random number do you want? And it's like, well, a random one, and it's like, which one? This is because computers are super instructional, right? Like you tell them exactly what to do. So the idea of doing something random to them is kind of inherently going against what they were designed to do, right? They don't really have that organic stuff to make that happen. So we can kind of fake this out by using seed values. So seed values are basically some type of catalyst that you're going to start the random generator with. Okay. Usually these seed values are going to be picked from things that are always changing in the world. The most common one, and the one you'll probably use in project 3, is the time of day, usually in milliseconds, right? Um, so if you can have a time of day in milliseconds, it's going to continuously change, and that seed value is always changing throughout the day. So when your computer is running, you can just pull that value real quick to seed your randomness with, and it's going to seem pretty random, right? With that said, if you were to somehow call that random function at the exact same time every day, like to the millisecond each time each day, it will actually give you the same set of random numbers because it's the same seed value, right? So that's just something to keep in mind. Other seed values can be like the temperature of the CPU. That's a little bit less random, but if you get to a certain number of digits, you can get that random distribution there as well. So that's kind of what's important to know about the seeding. With all that said, you guys don't need to necessarily do anything with it in this lab. You are just going to be using the random function. So the randomness aspect is already set up for you guys. You don't really need to touch or deal with it. You just need to call the random function. Okay. And basically, the random function is going to represent an actual die roll. So each time the random function is called, it's going to be a time the die has been rolled. Okay. And the user is going to put in how many times the dice are rolled, so you can kind of see how many times that random function needs to be called. And then one thing you'll need to note is you need to initialize all your key values to 0. So all the key value or all the keys again are just the 1 through the number of sides on the die. So each one of those keys need to have a value of 0 to begin with, because if they don't, it's going to have a bunch of garbage. And when you print this out to actually see how many times it's rolled, these numbers, if they were never rolled, won't be 0. They're going to be some crazy number, right? It's just like any other integer that you need to initialize. Otherwise, the system is just going to pick some random memory value. Let's see. I think that's it for this one. Not the whole lab, but just this part. Are there any questions? Oh, wouldn't the current Unix timestamp be a better seed than the time of day? Yeah, that would be a good one as well, Christian. So it's either or on what you want to use, but good question, and you can do that as well. Yeah. So when you do project 3, you can pick that one for sure. Cool. Any other questions? Yeah, because Christian, you'll get less of a chance, albeit slim, to get the same seed, for each time of the day. So, all right. So we can go on to part 2. Um, so with part 2, you guys are reading in a CSV file, similar to what you guys did in Lab 4, right? So Lab 5 and Project 2, those were binary files. We're going back to CSVs, okay? So you guys need to use the get name, or excuse me, get line call, and that's what you'll be doing. It's a CSV file again. Most of you made some type of Lego class. That's the same thing you'll want to do here, and he tells you to do that. So all of these are information about different states. So each row here is probably going to represent a class, right? So you're going to want to make a class or a struct that has a state name, the per capita income, population, median household income, and the number of households. And then once you do that, you can just make a map. We're using maps again, obviously. You can make a map with a string name, which the key is going to be the actual state, because all of those are going to be unique. And then you will associate a object of your class that represents that state. So basically, this is a way to organize a data structure where you can then search your map by state and get all the information of that state that you need, which is pretty much what we end up doing here. So the two functionalities you need is just print all the states. That's just going to be looping through your map and printing everything out. And then the functionality 2 is just going to be searching for a state. So you just type in the name of the state, which should be your key value. And then what it should print out is the name or all the information rather of your state. So it basically just going to go through the object and print all its attributes out. So when talking about the keys, you can use the find function, and then you also need to deal with iterators, which I went over a little bit last week. I'm more than happy to go over it for you guys if you want to refresh. But basically, you're just going to make a loop that starts at the beginning and goes to the end while it tries to find a key value. Yep. And that's actually pretty much it. Really, the meat of this lab is just understanding the map syntax and how to deal with it. There's not a whole lot of logic in here per se, as far as like doing like data crunching or like calculations and stuff like that. So just a lot of understanding on how maps work. Yeah. So that's pretty much it on this. Any questions on this? All right, cool. Let's see here.